It has one input, maybe x1 is input and y1 as input. A subsystem, G1 is subsystem represented by a single differential equation. G2 is another subsystem represented by another equation, another differential equations. We have seen for a mechanical system if it has three masses means, then three differential equations will be there. You can draw three such blocks like this. For each differential equation, we will write one block. So this system made up of 5 differential equations. That's why 5 blocks are there. If you connect all these blocks like that, you can get the system. Because one output of the first subsystem is input to the next system. The output of this system is input to the another system. In other words, output of G4 and G2 and output of H1 are combined together and given as input to G3. Output of G3 is final output. In addition, the output is fed back. Like in a car example, we have seen a feedback. So this is the feedback path. This is another sub-feedback path. If you combine all these things, you will get the entire system. We can find a transfer function C of S upon R of S. This is output C of S, input R of S. The Laplace transform of output upon Laplace transform of input is transfer function. Transfer function. We can find the transfer function by manipulating the 5 equations. How many equations will be there? For each block, one equation will be there. 5 equations will be there. If you combine all the 5 equations, you will get the transfer function like this. You have to manipulate all the 5 equations. Sometimes it's very difficult to manipulate 5 equations. In that case, if you represent in terms of block diagram, it can be simplified. That is called block diagram reduction. Here you can find C of S, R of S by reducing this block diagram. For that, 7 rules are there. Already we have seen 2 rules. The 7 rules today we'll see. Another thing, the first rule is, we'll see the first rule. If 2 blocks are cascaded like this, this is called cascaded blocks. 2 systems are cascaded. It means the output of first system is input to the second system. Output of first system is input to the second system. That is called cascaded system. If 2 systems are cascaded, then we can multiply the 2 transfer functions. If 2 systems are represented in time domain, say G1 of t, the output of G1 of t is input to the second system G2 of t. The input of the system is x of t, output of the system is y of t. If you want to find y, you have to convolute G1 and G2. Then only you can find y. The convolution is integral of minus infinity to t G1 of tau, G2 of t minus tau, d tau. This is in time domain. You know how it is difficult. You studied signals and system. That's why you know finding convolution of 2 systems, 2 time domain systems. Convolution of 2 time domain system is how it is difficult. It is in time domain. If you represent this in frequency domain, this will be represented as G1 of S, a transfer function. This will be represented as G2 of S in Laplace domain or frequency domain. If they are cascaded like this, then we can simply multiply. So convolution in time domain is multiplication in frequency domain. Converse also true. Convolution in frequency domain is multiplication in time domain. Already studied that. That's why multiplication is simple. Finding convolution in time domain is difficult. That is one of the reasons it is represented in frequency domain. The systems are represented in frequency domain. So if two systems are cascaded and if they are represented in frequency domain, to find the overall system, we can simply multiply the two blocks. That is first rule. Cascaded blocks with the transfer function G1 of S and G2 of S can be replaced by a single block with a transfer function equal to the convolution of transfer function of individual blocks. Convolution in frequency domain is multiplication. Convolution in frequency domain is multiplication. G1 of S multiplied by G2 of S. If two blocks are in parallel, second rule. If two blocks are in parallel, one block is G1 of S and another block is G2 of S. They are parallelly connected. They are summed together. The output of the two blocks are summed together. Input is same. The input to the first block and the second block both are same. But output is here X2 of S because different system. Here X1 of S. These two can be added, then you will get the final output if they are in parallel connection. Therefore, the equal transfer function is C of S upon R of S equal to C of S upon R of S equal to G1 of S plus G2 of S. They can be summed together. Parallel blocks with the transfer function G1 of S and G2 of S can be replaced by a single block with the transfer function equal to sum of transfer functions of individual blocks. That is second rule. Third block. In the block diagram, you can say that this is called takeaway point. The output of G1 is given to G2 as well as G4. That's why this point is called takeaway point. Here, this is called a summing block. Summing block. All the signals, all the outputs are summed together. This is takeaway point. This is also takeaway point. Takeaway is simple connection, but summing is a summing block is required. Here also summing block. But here, because of the sign, the subtract. Even subtraction also can be called as summing. Positive value and negative value are summed together. You can say like that. So here, this block consists of two summing blocks and three takeaway points. Three takeaway points. If you want to reduce this to a, we'll see later. By using the 7 rules, we will reduce this to a single block, single transfer function C of S upon R of S. We'll find that. But to reduce that, we have to move this takeaway point ahead of block or sometimes before that block. Like that, we have to move. For that, some rules are required. We should know the rules. So, the moving a takeoff point or takeaway point to the right. So, I want to move this takeaway point or takeoff point from 1 to 2, point 1 to point 2. Then only I can reduce the block diagram. If you want to move that, what is the problem here? This x1 signal is coming through this line to G1, G. The same x1 is going through this also. If you shift that, what will happen? Let us assume that G is gain, simple gain, K. If x1 is passed through means it is amplified. So here we are getting without amplification. Here we are getting amplified by G of S. But if you shift that, the takeaway point is amplified signal. This is a amplified signal. So I have to reduce the magnitude by 1 by G of S. So that's why if you shift that point from here to here, then the signal should be multiplied by 1 upon G of S. Because it is already multiplied by G1 of S. To nullify that G effect, I am dividing by G of S. Suppose the takeaway signal is one is amplified by G of S, another one is amplified by H of S. But you want to move the signal from here to here. While moving that, here it is amplified by G of S. I want to nullify the effect of G of S. That's why I am dividing this by G of S. That's all. This is possible in frequency domain only. In time domain, you have to do convolution integral. Therefore, to shift the takeoff point to the right of the block, divide the takeoff branch by G of S. That is the rule, third rule. Rule number 3. Suppose you want to shift the takeoff point to the left. Earlier, we shifted to the right. Here, we want to shift back. Backward shift. There we did the forward shift. Here, I want to shift the signal, takeaway signal from here to here. In that case, it is already amplified by G of S. The x1 of S is already amplified by G of S. Here, what you will get? Here, y1 equal to G of S multiplied by x1 of S. But if you shift that, G1 of S will not be there. That's why we have to multiply again by G of S. Very simple arithmetic. But these are all we should remember. Then only we can reduce the block diagram. So it should be multiplied by G of S. Then only both will be equal. X1 and Y1 will be equal if you do like this. Suppose this takeaway point already multiplied by H of S means you have to multiply H of S and G of S. That's all. Then you can shift this point from here to here. That is rule number 4. To shift the takeoff point to the left of the block, multiply the takeoff branch by G of S. This is rule number 4. Rule number 5. Suppose you want to shift the summing point forward shift ahead of the block G of S. You want to shift. Then only you can simplify. But here, X1 signal is coming in. X2, X1 as well as X2 both are summed up. Then it is amplified. If you shift this point from here to here, what will happen? The signal X2 of S is not amplified by G of S. So what we can do is, if you shift, it is not amplified by G of S. That's why what we can do is, we can amplify that signal by G of S. Then we can sum. Then both signal will be equal. Here what you will get? C of S equal to G of S X1 of S plus G of S X2 of S. Here also what you are getting? The same. C of S equal to X1 of S multiplied by G of S. X2 of S also multiplied by G of S. but here minus sign is there. So I should put minus sign. So here also you will get g of s multiplied by x1 of s minus g of s multiplied by x2 of s. Suppose the incoming signal is already multiplied by h of s, then you multiply both by h of s and g of s, because in frequency domain, two blocks can be multiplied together if they are cascaded. How you will add? If you want to add, this will be added like this. It will be added like this. It will be added like this. Two blocks. G1, H of S. It will be like this, like that. Instead of this. In that case, first rule says what? These two blocks can be multiplied together. That's why we can write G of S, H of S. Then what you will get here, in both blocks give the same output. G of S, X1 of S plus G of S, H of S, X2 of S. So both give same output. Therefore, rule number 5 is to shift the summing point to the right of the block. Multiply the signal entering the summing block by G of S. Don't remember the rules. Just to think whether it is amplified or not. If it is not amplified, you have to divide. If it is already amplified, it means you have to multiply. That's all. That way you have to think. So up to 5 rules, you can easily remember. The 6th rule is the opposite way. Moving the summing block backward shift. If you do the backward shift, this signal is not multiplied by G of S, but if you shift here, it will be multiplied by G of S. That's why what we have to do to compensate that, here x1 is not multiplied by G of S, because it is multiplied, it is not amplified because it is added after the block. But if you shift the summing block before this block, what will happen? This will be amplified by G of S. To nullify the effect, we are done multiplying by 1 upon G of S. Therefore, the rule is to shift the summing point to the left of the block, divide the signal entering the summing block by G of S. Of course, if it is multiplied by H of S before entering the summing block, then the answer is H of S upon G of S. 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 These are the 6 rules. No need to memorize the rules. By looking at it, we can find. From my explanation, you can understand the 6 rules easily. What is the first rule? If 2 blocks are cascaded, just to multiply. The 2 blocks are in parallel, just to add or subtract, depends upon the sign. Third rule, shift the summing block ahead of the block after a forward shift. If you want to do the forward shift, what you have to do is, it is not amplified. It is not amplified. It is not amplified. If you shift that, it will be amplified. Therefore, divide. That's all. That signal is after takeoff. If it is multiplied by H of S, means multiply by H of S by G of S to nullify the effect of G of S. Second rule, if you shift before the block, backward shift, if you want to do the same effect, it is already multiplied by G of S. If you shift here, it is not multiplied by G of S. Therefore, you have to multiply by G of S. That's all. If it is multiplied by H of S, multiply G of S, H of S. That is 4th rule. 5th rule, if you want to shift to the summing block, the signal is not amplified by G of S. That's why first amplify, then add. First amplify, then add. Similarly, if you want to move the block, summing block backward shift, it is not amplified by G of S. That's why divide by G of S. Divide by G of S. So you can easily remember the 6 rules. 7th rule is different. Seventh rule is, it says R of S equal to R of S and C of S are input and output. You have to find C of S upon R of S. C of S upon R of S, you have to find. This is summing block. This is summing blocks. Let us call this signal as B of S. Feedback signal. Let us call it as B of S. What is the signal that we are getting here? What is the signal that we are getting here is E of S equal to R of S minus B of S. Am I correct or not? B of S. Here, what is the input to this signal? C of S. C of S. B of S equal to what? R of S. B of S equal to what? Input is C of S. Output is B of S. That's why we can write H of S, C of S. Can I write like that? H of S, C of S. What is C of S? C of S, let it be 1. Am I correct? C of S is the input. What is the transfer function for this block? What is the transfer function for this block? Output by input. What is output? B of S. What is input? C of S equal to the transfer function H of S. That is the definition for transfer function. What is the definition for transfer function? Laplace transform of output by Laplace transform of input equal to transfer function. What is the transfer function? H of S. What is the output? B of S. What is the input? C of S. Therefore, B of S equal to H of S multiplied by C of S. That's why I wrote, instead of B of S, I wrote H of S multiplied by C of S. Any doubt in this point? B of S can be written as H of S multiplied by C of S. Now, what is C of S? Output. The C of S is equal to the same way C of S. What is the transfer function G of S? Transfer function G of S equal to Laplace transform of output C of S upon E of S. Am I correct? Therefore, C of S equal to G of S multiplied by E of S. G of S multiplied by E of S. Am I correct or not? Because this is one transfer function. The output is C of S, input is E of S. Therefore, C of S can be written as G of S multiplied by E of S. This is second equation. Now, we can substitute E of S from the previous equation. G of S multiplied by, what is E of S from the first equation? R of S minus H of S, C of S. Or you can write G of S, R of S minus G of S, H of S, C of S. C of S equal to G of S, R of S, G of S, R of S minus G of S, H of S, C of S. You can bring C of S to the left hand side. C of S to the left hand side. Why the C of S is coming in the output? Some feedback is there. That's why it is coming. Feedback is there. The output is fed back as input to the system. That's why the C of S is coming. If output is coming, the right hand side means some feedback is there. So G of S, if you bring all C of S to the left hand side, what you will get? C of S plus G of S, H of S, C of S equal to G of S, R of S. G of S, R of S. Therefore, I can take the C of S outside. Therefore, C of S 1 plus G of S, H of S. 1 plus G of S, H of S equal to G of S, R of S. If you find the overall transfer function, what is the input? R of S. What is the output? C of S. We need C of S upon R of S. Laplace transform of output by Laplace transform of input. That is equal to C of S upon R of S equal to G of S. Right hand side, what we are having is G of S. R of side is brought to the left hand side. Only G of S is there. Left hand side, 1 plus G of S, H of S is there. That we can bring to the right hand side, G of S, H of S. Therefore, C of S upon R of S equal to, if this is the block diagram, it consists of two blocks like this, means this can be simplified like this. G of S upon 1 plus G of S, H of S. So here what we did is, this feedback signal is, the feedback signal is, this is the feedback signal. This is the feedback signal. This is the feedback signal. This is the feedback signal that is removed. And we got a simple transfer function G of S upon 1 plus G of S, H of S. What we have to remember here is, this minus sign we should remember. This minus sign we should remember. If minus sign is there in the formula, what you will get? This plus you will get. This plus you will get. So how to simplify this? How to simplify this? Suppose I am having a transfer function like this. This is R of S. G of S. The output is C of S. The feedback signal is H of S. The negative feedback. The formula is C of S upon R of S, because Laplace transform of output upon Laplace transform of input equal to, what is in the forward path you have to see. What is the forward path? Suppose I am in Pondicherry. I want to go to Kadalur means, this is forward path. This is forward path. This is what? Going to Kadalur, then coming back to Pondicherry. Feedback path. Return back. So this is in forward path. What are the elements are there? Only G of S. That is in the numerator. Denominator, it should be, what is the closed paths? What are the elements in the closed path? G of S and H of S. Here minus sign is there. Therefore 1 plus. Minus sign is there. Therefore 1 plus G of S, H of S. G of S, H of S. Suppose plus sign is there. Then what is the formula? Then the formula is G of S upon 1 minus G of S, H of S. If it is plus sign is there, positive feedback means 1 minus G of S, H of S. For positive feedback means G of S divided by 1 minus G of S, H of S. This is the seventh rule. Only seventh rule you have to remember. All other rules are, you can understand by looking at the block. You can understand by looking at the block. Now, suppose I am having, these are all additional rules. Suppose I am having a summing block like this. How many signals are summed together? Q of S, E of S, R of S. All the three signals are summed up. How you can add all the three signals together? Suppose I am giving 3 numbers to you. How you will add? First you will add first 2 numbers. With that result, you will add the third number. The same concept. First 2 signals are added together. Then the third number is, or third signal is added together. So we can separate these two like this. The block diagram, we can separate the summing blocks like this. Similarly, if the 2 separate summing blocks are there, we can add it together like this. If you have the ability to add 3 numbers together, some people are like that. I've seen some videos. If you give 10 numbers together, they will add. We cannot. So, points to be remembered while doing block diagram reduction. The block diagram consists of many feedback loops. Then find the innermost feed block. Many blocks are there. We cannot do all at a time. So, we have to simplify one by one. You have to see the innermost block. First, simplify the innermost block. Then, if does not contain any takeoff or summing blocks, the inside, that innermost block should not contain any takeoff or summing block. Then only you can add. Then third point is, if consists of any takeoff point or summing block, move that takeoff. That's why the rules we have seen. Move that summing block or takeoff point away from that block, then simplify that. That's all. The path consists of any cascaded blocks. Combine them using rule 1. If they have parallel paths, add together second rule. Repeat the above steps. Algorithm. Repeat the above steps from 3 to 6 continuously. You will get a single block diagram. Now we will see this. This is 7 rules in nutshell. All the rules in nutshell. If the blocks are cascaded, you can multiply them. The blocks are parallel. Both are summed together. Both plus G1 plus G2. If you want to move the takeoff point from here to here, divide by G. If you want to move the takeaway point from here to here, multiply by G. If you want to move the summing point from here to here, the same rule. Here we are dividing because it is takeaway. Here we are multiplying, inverse. Similarly, if you want to move from here to here, the opposite to takeaway, divide by 1 by G. 7th rule, you know, G upon 1 plus GH. G upon 1 plus GH is the 7th rule. G upon 1 plus GH for negative feedback. If it is positive feedback, G upon 1 minus GH. That's all. Now, the another supplementary rules are, you can combine these two summing blocks together, or you can separate the summing blocks. That is the additional rules. You have to reduce the block diagram. The question may be like this. Reduce the block diagram, or simplify the block diagram by using block diagram reduction technique, or find the transfer function C of S upon R of S by using block diagram reduction technique. You have to reduce the block diagram. The question may be like this. Reduce the block diagram, or simplify the block diagram by using block diagram reduction technique, or find the transfer function C of S upon R of S by using block diagram reduction technique. So what is the first step? We have to look at the innermost part. This is the innermost part. In the innermost part, we cannot multiply these two blocks. Why? Because takeoff point is there. That's why we cannot multiply these two. So we have to move this takeoff point from here to here, so that or here to here, as you wish. You can do in both ways. Anything you wish can be done. So if you want to move this way, what you will get is, in the examination, you have to draw again the block. For each step, you have to draw the block again and again. G2, what second level? So here we have to move this block ahead of this point. Means what will happen? It is already amplified by G1, but it is not so if you move that. That's why we have to multiply by G1. G1, we can write G4 also like this, because two blocks can be multiplied. That's all. Sorry. Then G3 is there. G3 is there. C of S and H1 is there. This is means this is unity feedback. Gain is unity, no amplification. This is minus sign. So these two can be multiplied together. That's why G1, G2 can be written. The next diagram, you have to write G1, G2. Now these two are in parallel. That's why we can write the another diagram. G1, G4 plus G1, G2. The feedback is there. Here, the next G3, H1, and another feedback is there. So now it is simplified like this. Now the innermost part is this. This can be simplified. Use seventh rule. We can write G3 upon 1 plus G3 H1. So this block is reduced. Now you will get one block here, another block here. That's all. Now if you multiply these two together, let us call them as, you can multiply these two together. Let us call them G5. G5 equal to what? G1, G4 plus G1, G2 multiplied by G3 upon 1 plus G3 H1. This is G5. G5 is here. Feedback is unity feedback. Then what you will get? C of S upon R of S equal to G of S G5 upon 1 plus G5 multiplied by 1, because unity feedback. That's all. So now you know what is G5. This is G5. This is G5. Substitute G5 and 1 here and take LCM. You will get a single transfer function. So this is called block diagram reduction technique. Okay, we'll see in the next class. Obtain the transfer function C of S upon R of S. Obtain the transfer function C of S upon R of S using block diagram reduction technique. In this case, we have to see the innermost part. Innermost part is this G1 and G2. But one takeoff point is there. That's why we cannot multiply these two. Either we have to move this to this side or this side. Suppose if you want to move to the left side, what will happen? The signal is the signal going to this G4 already multiplied by the gain G1, transfer function G1. If you shift that, it will not be multiplied by G1. Therefore, we have to multiply by G1. So what we can do is G1, G2, G3, here G1, G4. Now, this can be separated into two summing junction and these two can be multiplied together. This can be multiplied together. If you multiply these two together, what you will get? G1, G4. If you multiply these two together, you will get G1, G2. These two are in parallel. And you can separate this like this. In this diagram itself, we could have done like that. This is G1, G4. Here, G1, G2. These two are coming from R of S. Again, another summing block, G3, H1, C of S. This is minus sign. This is also minus sign. This is plus. This is plus. This is plus. So this, by using seventh rule, we can simplify this. So this is equal to what? G3 upon, because negative feedback, that's why 1 plus G3 H1. These two are parallel, that's why we can write G1 G4 plus G1 G2 for this. Then one more feedback, that's all. So we can simplify the given block diagram as in this G1 G4 plus G1 G2. And it is given to G3 upon 1 plus G3 H1. So now these two are cascaded blocks. Now these two can be multiplied together. What we will get is G1 G4 plus G1 G2 multiplied by G3 upon 1 plus G3 H1. This is in the numerator. Forward path. R of S and this is C of S. Now we have to apply the seventh rule and simplify this. Here feedback is 1. No block is there, we have to take it as 1. So what we get is 7. If you apply seventh rule, forward path transfer G1 G4 plus G2 G1 G4 G1 G2 G1 G2 multiplied by G3 upon 1 plus G3 H1. That's what we got. G3 H1 whole divided by, because of this feedback path, 1 plus the entire thing we have to write. G1 G4 plus G1 G2 multiplied by G3 upon 1 plus G3 H1. If you take LCM, these two get cancelled. So this is equal to G1 G4 plus G1 G2 multiplied by G3 upon 1 plus G3 H1 upon, if you take LCM, what you will get? 1 plus G3 H1 plus G1 G4 plus G1 G2 multiplied by G3 upon 1 plus G3 H1. This and this getting cancelled. Therefore, G1 G4 G3 plus G1, G2, G3 upon 1 plus G3, H1 plus G1, G4, G3 plus G1, G2, G3. So this is the final transfer function. So we simplified. So this system is represented by 1, 2, 3, 4, 5 differential equations. If we know the transfer function, we can substitute here and we can find a single transfer function. So that is possible by using block diagram reduction technique. This technique is called block diagram reduction technique. Another method is signal flow graph method. We can represent this block diagram in terms of signal flow graph. So the same block diagram can be represented in signal flow graph. For that, R and C are called node, already studied node in circuit, electric circuit analysis. Node means junction, but misnamed. Even two elements are meeting, we are calling it as node. So like that here, R is one node and C also another node. This is called source node. And this C is called sink node. Starting node is called source node. End node is called sink node. All other takeoff point as well as summing points will be marked as node. First node, this is second node, this is third node, fourth node, fifth node, sixth node, seventh node. Therefore, C is seventh node, R is first node. Now we can draw all other nodes. Second node, third node, fourth node, fifth node, sixth node. That's all. We have to mark the directions. Direction is from 1 to 2. From 2 to 3. 3 to 4. 4 to 5. 4 to 5. 5 to 7. 5 to 6 also in the same direction. That's why 5 to 6. Then 6 to 4. 6 to 4 this direction. 6 to 2 also the same direction. Feedback direction. And 3 to 4 one direction. 3 to 4. That's all. We have marked the direction only. Now we have to mark the gain. This type of representation is called signal flow graph representation. Signal flow graph representation. SF representation. Signal flow graph representation. In the signal flow graph representation, each link will have a gain. For example, this may be G1 between node 2 and 3. If no transfer function is there, for example, between 5 and 6. 5 and 6, if you see, no transfer function, gain is unity. That's all. So these and all we have to mark. That's all. 1 to 2, no gain, no transfer function 1. 2 to 3, G1 is there. 3 to 4, G2 is there. 3 to 4, another one is there. That is also G4. That is G4. 4 to 5, G3. 6 to 4, H1. But here negative feedback. That's why minus H1. Negative feedback. That's why minus. Here, no transfer function is there, but minus. Therefore, minus 1. 5 to 7, no transfer function. Therefore, 1. All marked G1, G2, G3, H1, and G4. Everything is marked minus 1 for 6 to 2. This representation is called signal flow graph representation. Each link has a gain. Each link has a gain. Each link has a gain. That's all. To find the transfer function, one formula is there that is called Mason's gain formula. Mason's gain formula. The transfer function T of S equal to 1 upon delta sigma Pk delta K. Pk delta, that is the formula. Sum of Pk delta K. 1 upon delta sigma Pk delta K. Where Pk is kth forward path. Gain product of kth forward path. That is Pk. Gain product of kth forward path. Pk. Here, how many forward paths are there? The source is R, destination is C. To reach the destination, there are 2 forward paths. One is 1, 2, 3, 4, 5, 6, 7. Another forward path is 1, 2, 3. Through this, we have to reach 4. Through this circular path 4, then 5, 7. There are 2 forward paths. So, there are 2 forward paths, P1 and P2. The gain products of P1 is G1, G2, G3. The gain product of first forward path P1 equal to G1, G2, G3. Whatever the weight there, we have to multiply. That's all. Gain product for the second forward path P2 equal to G1, G4, G3. That is Pk. We got Pk. How many Ks are there? 2. Only 2 forward paths are there. Only 2 forward paths. One is G1, G2, G3. Another forward path is G1, G4, G3. That's all. To reach 1 to 7. No other forward path. This is one-way traffic. You cannot travel through this because direction is important. You cannot travel this path. 4, 6, 5, 7, you cannot travel because direction is against. Similarly, you cannot travel 2, 6, 5, 7, but you can travel 1, 2, 3, G2, 4, 5, 7, you can travel. 1, 2, 3, G4, 4, 5, 7, you can travel. These only 2 forward paths are there, whose gains are G1, G2, G3. Another gain is G1, G4, G3. That's all. What is delta? Delta is 1 minus. Delta is the name of delta is determinant of the graph, that is delta. But definition only if you know, that is sufficient. Determinant of the graph delta equal to 1 minus sum of gain products of individual loops. Loop means, suppose you are starting at 2 means I am traveling like this. 2, 3, 4, 5, 6, again 2. That is one loop. Another loop I am telling. 2, 3, G4, 4, 5, 6, 2. Another closed loop. Another loop. One more loop I am telling. 4, 5, 6, 4. These are all loops. These are all loops. The gain product of loops means whatever gain you mentioned, you multiply all those things. Gain product, what is it? First loop, L1. L1 equal to what? G1, G2, G3 minus 1. Therefore, minus. This is equal to minus G1, G2, G3. L2, second loop, sum of gain products of individual loops. Single loops. Individual loops or single loops. Sum of gain products of another loop is what? G1, G4, G3 and minus 1. How I am traveling? G1. Now I am traveling G1, G4, G3. Then I am coming here. This is second loop. This is L2. First loop is how? First loop is this way. First loop is this way. Third loop is what? Third loop is 4, 5, 6. 4, 5, 6. L3 is L3 equal to 4, 5, 6. G3 minus H1. Because H1 is in minus. Gain of 5 to 6 is 1. Gain of 5 to 6 is 1. L1, L2, L3. Delta equal to what? 1 minus sum of gain products of individual loops. That is nothing but L1 plus L2 plus L3. L1 is what? Gain products of individual loops. Gain products of individual loops. L2 is gain products of another individual loop. L3 is gain product of another individual loop. This is not loop. I am traveling this way. 3, 4, 3, G4, 4, G2, 3 is not loop. Why? Why it is not loop? Direction is not in favor of traveling. If you travel 3 to 4 through G4, you are traveling as per direction. If you travel from 4 to 3, it is against direction. So you cannot travel. I understand that. Only 3 loops are there, not 4 loops. This is not loop. This is not loop. This is not loop. This is not loop. Not loop. Why? Because 3 to 4 you can travel through G4, no problem. But you cannot travel 4 to 3. Again, you cannot reach the same point. There is no path. Because the direction is not in favor. Direction is not in favor. That's why it is not loop. Loop means the direction also must cooperate. Then only you can reach the same point, means it is a loop. But if it is different path, means different loops. There are only 3 loops are there. In the diagram, only 3 loops are there. What is delta? Delta is 1 minus sum of gain products of individual loops plus, I am putting minus here, now plus sum of gain products of gain products of two non-touching loops. Non-touching loops. Sum of gain products of two non-touching loops. Is there any non-touching loop? You see that L1 and L2 are touching each other. L1 and L2 are touching each other. L2 and L3 are touching each other. L1 and L3 are touching each other. Therefore, there is no two non-touching loops. How we can group this? 2, 2, 2. If you group this as 2 loops, L1, L2, L2, L3, and L1, L3. Only 3 possibilities of combinations. Two non-touching loops. If you check L1 and L2, they are touching each other. That's why they are not touching. They are touching loops, not non-touching loops. What is the formula? Sum of gain products of two non-touching loops. But they are touching. That's why you cannot take. Have you understand this point? L1 and L2 are touching each other. Therefore, they are not touching loops. They are not non-touching loops. They are not non-touching loops. L2, L3, if you take, they are also touching. Therefore, they are not non-touching loops. If you take L1 and L3, they are touching each other. Therefore, you cannot take. Therefore, second term, you won't get. The green term, you won't get. Now, if you take one more term, if you write the third term, sum of gain products of three non-touching loops. Three non-touching loops. There is no two non-touching loops. Then how three non-touching loop will be there? Definitely it won't be there. Etc. Here minus sign. Here minus sign. Plus sum of gain products of four non-touching loops. Infinity, up to infinity. There is no two non-touching loops. How there will be three non-touching loops? No. Four won't be there. That's all. Therefore, this term is not there. This is also not there. The formula delta equal to 1 minus sum of gain products of individual loops. Now I think you got the meaning of individual loops. All loops must be taken first time. Second time, if they are not touching two loops, a group of two loops not touching each other means, then you can consider. For example, I am having a loop like this. Non-touching loop, I will give you example. One forward path. One loop is here. Another loop is here. Another loop is here. This is L1. Loop 1, loop 2, loop 3. L1, L2, if you consider, non-touching. L1, L2 are non-touching loops. L2, L3, non-touching loops. L1, L3 also non-touching. L2, L3 also non-touching. Therefore, three components you will get. Suppose the gain of this L1 is G1, H1, G2, H2, minus H2, G3, H3. For example, the second term you will get L1, L2 equal to G1, H1 minus L2, L3 equal to G1, H1, G2, H2 plus, because both minus, that's why it becomes plus. If you consider L2 and L3, you will get G2, G3, H2, H3. Positive. Why? Both are negative. Then what you will get? L1, L3. They are also not touching. Therefore, G1, G3, H1, H3. Sum of these components has to be substituted in the place of green term. In this case, no two non-touching loops. If it is there, we have to consider. It is there, we have to consider. In this case, is there any three non-touching loops? Yes, it is there. L1, L2, L3 are not touching each other. Therefore, you will get one term L1, L2, L3 equal to G1, G2, G3, H1, H2, H3 minus, because three negative terms, therefore minus. Have you understand this? So like that you will get, but here no two non-touching loops, no three non-touching loops. Therefore, no three non-touching loops. There is no two non-touching loop means how there will be a three non-touching loops. Definitely won't be there. Only three loops are there, four non-touching loops, how it will be there? That's why you need not bother. So it's we should be careful about number of loops. If you lose some loops, some will be wrong. That is the drawback with this sum. Okay, now we got L1, L2, L3, only individual loops, no non-touching loops. We can write the formula. Delta means what? 1 minus sum of gain products of individual loops. All of the terms are not there. There is no two non-touching loops. There is no three non-touching loops. That's all. So delta is we got. Delta we got. Now we do not know what is the meaning of delta K. That we have to find. In that formula, P1, P2 we got two forward paths are there. Forward path gains are G1, G2, G3, G1, G4, G3. That we got. But what is delta K? Delta K is delta 1. How many Ks are there? Only two Ks are there. Delta 1, delta 2. Because P1, P2 is there. Two forward paths are there means delta also only 2. Delta 1, delta 2. Delta 1 means delta 1 is delta of part of graph which is not touching the forward path 1. Which is not touching the forward path 1. What is the forward path here? This is the, I will draw in the block diagram because here you cannot understand. That's why this is the forward path 1. Is there any loop which is not touching the forward path? No loop or not. Therefore, delta 1, delta of delta forward path P1 equal to 1. That's all. Because formula starts with 1 minus. Starts with 1 minus, only 1. Because no loops are not touching the forward path. Second forward path, which is second forward path. This is the second forward path. This is the second forward path. This is the second forward path. In the second forward path, any loop which is not touching the second forward path, no. Therefore, delta 2 also equal to, delta 2 also equal to 1. Delta 2 also equal to 1. If you combine all these things, you will get the transfer function. If you combine all these things, you will get the transfer function. Let us combine. What is the formula? Mason's gain formula. T of S, that is C of S upon R of S, that is the transfer function equal to 1 by delta sum of P1 delta 1 plus P2 delta 2. Sum of means what? P1 delta 1 plus P2 delta 2. What is P1? P1 is G1, G2, G3. What is P2? G1, G4, G3. What is delta 1? 1. What is delta 2? 1. Therefore, what is delta? Delta equal to L1 plus L2 plus L3. So we can substitute here and you will get the transfer function. What is that? We will write here so that we can compare. C of S upon R of S equal to, what is P1 delta 1? What is P1? P1 equal to G1, G2, G3. P1 equal to, formula is what? P1 delta 1 plus P2 delta 2 upon delta. That is equal to P1 equal to G1, G2, G3 plus, what is P2 multiplied by delta 1, that is 1. What is P2? G1, G4, G3 upon delta 1 minus delta L1 plus L2 plus L3, that is equal to G1, G2, G3 plus G1, G4, G3 upon 1 minus, what is L1? L1, what is L1? minus G1, G2, G3 minus G1, G minus G1, G2, G3 minus L2 is G1, G4, G3. G1, G4, G3. What is L3? Minus G3, H1. Minus G3, H1. Minus G3, H1. Therefore, the given transfer function is G1, G2, G3 plus G1, G4, G3 upon, because all terms are with negative, that's why 1 plus G1, G2, G3 plus G1, G4, G3 plus G3, H1. What we got? G3, H1 in the 1 plus is there. Here also 1 plus. G3, H1. Yes, it is there. G1, G4, G3. That is also there. G1, G2, G3. That is also there. The numerator G1, G4, G3 is there. G1, G2, G3. That is also there. In both methods, we got the same result. The first method is called block diagram detection. The second one is called signal flow graph. You have to convert the given block diagram into signal flow graph, and then you have to obtain the mathematical model. So what is Mason's gain formula? Sigma Pk delta K upon delta, or 1 by delta multiplied by sigma Pk delta K. What is Pk? K number of forward paths. It varies from graph to graph. Number of forward paths depends upon the graph. In this case, number of forward paths equal to 2. Therefore, K varies from 1 to 2. What is delta 1? Delta 1 is nothing but delta for the part of graph which is not touching the forward path 1. What is delta 2? Delta 2 also delta. We have to find a delta which is not touching the second forward path. There is no graph which is not touching the first forward path and second forward path. Therefore, delta 1 equal to 1. Delta 2 also equal to 1. What is delta? Delta equal to 1 minus sum of gain products of individual loops plus sum of gain product of all combinations of all possible combinations of two non-touching loops. We have to check L1, L2. We have to check L1, L3. We have to check L2, L3. How we can find from the expression itself? We can find how here G1 is common. If you see L1, L2, if you consider L1, L2, G1 is common. Therefore, definitely they are touching. If you consider L1 and L3, G3 is common. If you consider L2, L3, G3 is common. Therefore, they are touching each other. They are touching each other. Sometimes they may be touching, but there won't be common elements. That is also there. For example, you should be very careful. That's why I'm telling. Here, for example, here one more loop is there. That is G4, H4. These two are touching each other, but there is no common elements. But L1 and L3 are not touching. L1, L4 are touching. Similarly, suppose here one loop is there. This is G5, H5. L2 and L3 are not touching, but L2 and this is L5. L5 are touching. L5 are touching, but there is no common elements. So don't take this as granted. Sometimes if you see L1 equal to what? L1 equal to, in this case, minus G1, H1. L4 equal to what? G4 minus G4, H4. But there is no common elements, but they are touching each other. They are touching each other. Therefore, we have to check But most of the time, common elements will be there. Quickly you can remove them. Quickly you can remove them. Sometimes there won't be any common element, but they will be touching each other. How many two non-touching loops, L1, L2? In this case, let us check. How many two non-touching loops? L1, L2 plus gain products of L1, L2, L1, L3. Am I correct? Plus L1, L5. That is also not touching. L1, L5 also not touching. Then take L2. L2. Take L2. With L2, L3 already wrote. L3, L1 already wrote. Only thing is L4. If you take L4, L5, if you take, they are not touching. L4, L5 are not touching. Am I correct or not? L4, L5 are not touching. Only one more loop, one more group you are getting. How many three non-touching loops are there? L1, L2, L3. Any other thing? L4, L5, one more you cannot find. L4, L5, if you take, you cannot find one more. Then only three non-touching loops. Only one three non-touching. Only L1, L2, L3. That's all. For that, what you have to do is you have to take all the possible combination. L1, L2, L3, L1, L2, L4, L1, L2, L5. But no need to consider these two because already L1, L2 are touching. Why we have to consider? We have to use our IQ. That is the drawback with this system. We cannot use it as a formula. We have to apply our IQ. IQ means it is not formula. You have to use your IQ means it is not formula. It is a thumb rule, not formula. So Mason's gain formula is a thumb rule, not a formula. We can say, but if you miss something, the answer will be wrong. You have to assume it as a thumb rule. Now, so what we have seen, we have solved the sum in two ways. One is block diagram reduction technique and signal flow graph. But signal flow graph will be simpler than block diagram reduction technique. But you can verify whether the answer is correct or not. By using signal flow graph, you can verify the answer by using signal flow graph. You can obtain through block diagram. After obtaining through block diagram, you can verify through signal flow graph. That way you can use the signal flow graph if it is not asked. If it is asked, you can solve with the signal flow graph only. Okay. Today we are going to see both methods, block diagram reduction as well as signal flow graph method. Both methods will see another two sums on this method. Given that the block diagram is given, we have to find the C of S upon R of S by using block diagram reduction method. In this, the first step is we have to find the innermost part of the loop. This is the innermost part. This can be easily converted. This can be easily converted to G4. This part is equal to negative feedback. That's why this is equal to G4 upon 1 plus G4H2 by using 7th rule. By using 7th rule, we can write like this. This also can be written. No need to write separate two summing blocks. This also can be. But summing block will be there because of this path. Because of this path, summing block will be there. But this feedback path can be removed by using 7th rule. This is equal to G1 upon 1 plus G1H1. These two are in parallel. These two are in parallel. That's why this can be written as G3 plus G2. Now, the block diagram can be reduced to G5, G4 among 1 plus G4H2. These two are parallel blocks. That's why G3 plus G2. And this is feedback. That's why we can write G1 among 1 plus G1H1. In the examination, you have to separate these two summing blocks in one step. Then you have to find the transfer function for these two loops. And then you have to add. The third step, you have to add these two. But here in one step, I did all the three things together. But in the examination, to give more steps, I do not know about the examiner. If I am going to be the examiner, no problem. So do more number of steps. You have to separate this summing block into two summing blocks. One, this forward path, another one for feedback. Like that, you have to separate this into two summing blocks. So now we can multiply all these together. This is equal to G5, G4, G3 plus G2 multiplied by G1 among 1 plus G4H2 multiplied by 1 plus G1H1. This is one step. Again, you have to draw like this. G1, G2 plus G3, G4, G5 upon 1 plus G4H2, 1 plus G1H1. Now we have to apply 7th rule. RC. If you apply 7th rule, what you will get? C of S upon R of S equal to G1, G2 plus G3 multiplied by G4, G5 upon 1 plus G4H2 multiplied by 1 plus G1H1. This is in the numerator. Forward path upon 1 plus G1, G2 plus G3, G4, G5 upon 1 plus G4H2 multiplied by 1 plus G1H1. If you take LCM, you will get G1, G2 plus G3, G4, G5 upon 1 plus G1H1 plus G4H2 plus G1, G4, H1, H2. I expanded this part. On, if you take LCM of this, what you will get? 1 plus G1, H1 plus G4, H2 plus G1, G4, H1, H2. This is instead of 1, because I am taking LCM, whole divided by plus this part we have to write. Numerator part we have to write. So G1 plus G2 plus G3, G4, G5 whole divided by 1 plus G1 H1 plus G4 H2 plus G1 G4 H1 H2. These two are getting cancelled. Therefore, the transfer function is C of S upon R of S equal to G1 G2 plus G3 G4 G5 upon 1 plus G1 H1 G4 H2 G1 G4 G1 G4 H1 H2 plus G1 G2 G4 G5 G4 G5 plus G1 G3 G1 G3 G4 G5. If we expand this also, you will get the numerator G1 G2 plus G1 G3 G1 G2 G4 G5 plus G1 G3 G4 G5, the numerator. Instead of this, in the numerator you can write G1 G2 G4 G5 plus G1 G4 G5 G3. The numerator. Instead of that, you can write this. So we got this. Why I expanded all this? Because if you use signal flow graph, you will get like this. To verify, it will be convenient. Otherwise, you can stop without simplifying, without expanding. So in the signal flow graph, we have to draw signal flow graph. We have to find the signal flow graph. This is source node. R is the source node 1. This is second node. This is third node, fourth node, fifth node, sixth node, seventh node, and the eighth node is the sink node. Eighth node is the sink node. Now we have to draw the signal flow graph. How many nodes? 8 nodes are required. G3, G2, G1, 1. This is also 1. This is 5, 4, 6, 7, 8. 7 to 5. One path is the feedback path, H1 minus H1, because negative feedback. 4 to 3. That is also minus H2. 7 to 2. One more feedback. 7 to 2. That is minus 1. That's all. This is the given signal flow graph representation of given block diagram. Now we have to find the transfer function. What is the formula? Mason's gain formula. T of S equal to 1 upon delta sigma pk delta k. Here also only 2 forward paths are there. Only two forward paths. One is 1, 2, 3, 4, G3, 5, 6, 8. Another forward path is 1, 2, 3, 4, G2, 5, 6, 8. Therefore, P1 equal to G5, G4, G3, G1. Another forward path, P2, is the circular path. We have to go through this path instead of this path. So P2 equal to G5, G4, G2, G1. Only two forward paths. Then we have to find the delta. To find delta, we need the loops. L1. The first loop is this. Minus G4, H2. Another loop, L2 equal to. This is not loop. This is not loop. Because the direction is not in favor of travel. But this is loop. 5, 6, 7, 5 is loop. That is minus G1, H1. Another loop. One more loop. 2, 3, 4, 5, 6, 7, 2. That is one more loop. L3 equal to minus G5, G4, G3, G1. That's all. L4 equal to another path we can find 2, 3, 4, G2, 5, 6, 7. That is another path. Therefore, that also can be written minus G5, G4, G3, G2, G1. That's all. G5, G4, G2, G1. Any other loops? Individual loops? No other loops. No other individual loops. This is not the loop. Between 4 and 5 is not the loop because the direction is not in favor to travel. But two non-touching loops are there. 3, 4, 5, 6 are two non-touching loops. 3, 4 and 5, 6 are two non-touching loops. That is G4H2 is what? G4H2 is L1. G1H1 is L2. G1L2 is a non-touching loops. Two non-touching loops. L1, L2. What is the gain? Plus G1, G4, H1, H2. That's all. No three non-touching loops. Definitely no, because two non-touching loops only there. How three? That's all. So we can find the delta. What is delta 1? Delta 1 is delta of part of graph which is not touching the forward path. First forward path. What is first forward path? G4, G5, G4, G3, G1. That is the first forward path. The part of graph which is not touching the forward path is only one node, that is 7. 7 is not touching the forward path. Suppose in the 7 you have a loop like this, that is called self loop. I didn't mention yesterday. That is called self loop. I am having a loop like this whose gain is G6, let us assume. Then that is equal, that will come in part of delta 1. But no such loops are there. But only one node is there. 7 is not touching the forward path. That's all. There is no loop. Therefore, delta 1 equal to 1. That's all. What is delta 2? Delta 2 is the another forward path. G5, G4, G2, G1. That is delta, forward path 2, P2. Forward path 2 is G5, G4, G2, G1. Part of graph which is not touching the second forward path is again 7 only. But 7 doesn't have any loop. 7 doesn't have any loop. The loop should not touch the forward path. But here 7 has one loop. 7 has one loop. That is G1, H1 is there. But it is touching the forward path. A part of graph which is not touching the forward path we need. But only one node is not touching. There is no loops which is not touching the forward path. Therefore, delta 2 also equal to 1. Delta 2 also equal to 1. Therefore, the transfer function is C of S upon R of S equal to P1 plus P1 delta 1. Formula is what? P1 delta 1 plus P2 delta 2 among delta. That's all. What is P1? P1 is G1, G3, G4, G5 multiplied by delta 1, that is 1, plus G1, G2, G4, G3, G4 multiplied by 1. P1 plus P1 delta 1 plus P2 delta 2 upon delta. Delta equal to what? Delta equal to 1 minus L1 plus L2 plus L3 plus L4 plus L1 L. That's all. Plus L1 L. This is delta. What is the formula for delta? 1 minus sum of gain products of individual loops plus sum of gain products of two non-touching loops. Only one, two non-touching loop, L1, L2. Therefore, delta equal to 1 minus, what is L1? L1 is minus G4 H2. L2 is minus G1 H1 minus G5 G4 G3 G1 minus G5 G4 G2 G1 plus L1 L2 is what? G1 G4 H1 H2. That's all. Only thing is you have to bring that minus sign inside. If you bring that minus sign inside, what you will get? Everything becomes plus. That's all. If we check with that block diagram reduction method, G1, G4, H1, H2, that is there. G1, G4, H1, H2 is there. G5, G4, G2, G1, that is also there. G5, G4, G3, G1, that is also there. G1, H1, that is also there. G4, H2, that is also there. 1, that is also there. Numerator, G1, G3, G4, G5 is there. G1, G2, G3, G4. G1, G2, G3, G1, G2. Something wrong. P1 is G5, G4, G3, G1. P2 is G3, G5, G4, G2, G1. G5, G4, G3, G1. Right, this is correct. This is G5, G4, G2, G1. Okay, now check. G1, G4, G5, G3. Yes, this is coming. G1, G2, G4, G5. Yes, now it's correct. Now it's correct. In both methods, we got the same transfer function. But in both methods, we got the same transfer function. Another sum. So this is this can be solved quickly. What are the forward paths? without drawing that signal flow graph I am writing. You can assume as if it is a signal flow graph. You can assume this as if it is a signal flow graph. Therefore, P1 equal to, this is gain 1, that's why ignore G1, G2, G3. G1, G2, G3. What is delta 1? Then P2. P2 equal to, this is another forward path, G4. That is G1, G4, G3. That is another forward path. We have to find delta 2. Now we have to find delta. Delta 1. What is the first forward path? This is the first forward path. No loop, which is not touching the first forward path. Therefore, delta 1 is 1. Delta 2, this is the second forward path. No loop is there without touching the second forward path. Therefore, delta 2 also equal to 1. In the examination, don't do like this. You won't get any mark. You have to draw the signal flow graph. Delta. Delta means 1 minus sum of gain products of individual loops. This is one individual loop. That is G1, G2, H1 minus G1, G2, H1. This is another loop. This is another loop. Minus G3, H2. Any other loops? One more loop is there. That is minus G1, G2, G3 minus G1, G4, G3. 4 loops are there. L1, this is L1, this is L2, this is L3 and L4. Non-touching loops are L1 and L1, L2 equal to, that is plus. These two are non-touching loops. Therefore, G1, G2, G3, H1, H2. That's all. I found the delta also. Now I can write the transfer function. C of S upon R of S equal to G1, G2, G3. Delta 1 is 1. That's why I am ignoring. Plus G1, G4, G3 upon 1 plus G1, G2, H1 plus G3, H2 plus G1, G2, G3 plus G1, G4, G3 plus G1, G2, G3, H1, H2. That's all. We got the transfer function. First time. You try yourself with the block diagram reduction technique. Block diagram reduction technique. So this we have to move. This we have to move. If we move 4 to 3, or 3 has to be moved to 4. You can do as you wish. If you move 3 to 4, what will happen? G2 is not there. Therefore, G4 by G2 you will get. G4 by G2. If you move 4 to 3, what you will get? G2 is excluded. That's why H1 will be multiplied by G2. H1 will be multiplied by G2. That's all. Anything you can do. Suppose let us move G4 to G3. Here you will get G2. Then you can simplify this by using 7th rule. This also can be used by 7th rule. This can be solved by using parallel 2nd rule. That's all. Then multiply all the 3 blocks. Only one feedback path will be there. Finally. So in 5 steps, you can find the transfer. Second sum part A group. Find the transfer function C of S upon R of S using block diagram reduction technique. Hence, verify the result by Mason's gain formula using signal flow graph. So here, see the direction. This passing through G3, one goes downward, another goes upwards. This can also be redrawn. One more block you can put G3, this goes down and this goes up, and you can disconnect the link here. Both are correct, you know. The signal passing through G3, one part goes to up, another part goes down, means G2, now G2, G3 are parallel, G3, G4 are also parallel. That is the critical part in this sum. G2, G3 are parallel, G3, G4 are parallel, but G2, G3, G4 are not parallel. I understand this point. G2, G3 are parallel. Similarly, G3, G4 are parallel. Where we have to add either with G2 or G4. No, both. We have to add G2 with G2 as well as G4. Because it is parallel to both G2 as well as G4. That's why G3 should be added to both. If you redraw the circuit, what you will get is G2 plus G3. So there is no need of summing junction. Many did, they have drawn the summing junction also. Once it is added means why summing junction is, why we added to remove the summing junction. After adding, why you are drawing the summing junction? Why we added G1 plus G2? To remove the summing junction. Once it is removed means why you are drawing that G2 plus G3 and a feedback loop G1 minus, this is plus. Then G5 is there. G5. G5. This is plus. Now, this signal is coming down. G3 should be added to G4 also. G4 plus G3. But this is going to this junction. Then G6. G7 minus. That's all. Now we can apply seventh rule here. We can apply now itself. We could have applied, but I didn't apply. Now itself we could have applied here. But here you cannot apply. Here you cannot apply. Why? Why you cannot apply here? Why you cannot apply here? Seventh rule cannot be applied here. Why? Because there is a takeaway point in between. Once it is converted into single block, means how you will take the takeaway point. You cannot take the takeaway point if it is converted into single block. If you convert this into single block, this is what G1. What I will get, many wrote, somebody wrote G1 wrong. This is wrong. G1 upon 1 plus G2, G3 multiplied by G. Which is forward path? This is forward path. G2 plus G3 is forward path, not G1. It is above, you know, that's why they are writing like this. This is wrong. Which is forward path? G2 plus G3 is forward path. G1 is feedback path. That's why that should be in the denominator only. This is in the numerator. G2 plus G3 is in the numerator. But anyhow, now we cannot convert. We cannot apply seventh rule here because of this takeaway point. Suppose you are converting this into single block. Say G2 plus G3 upon 1 plus G2 plus G3 multiplied by G1. If you convert this, from where you will take this? It is converted into single block. How you will take that takeaway point? You cannot take. That's why we have to remove that first. Then only you can convert. So to remove that, we do not have any rule to move out of summing junction. Take away points, we can move. If under worst condition, we can move. I'll let you know later. I don't want to confuse you now. You will get one, suppose, I'll tell now, but don't apply it. Suppose I want to move this here. I want to move this here, let us assume. Then no problem. You can move here very much. G4 plus G3 will come. But this path also going through this, that is not considered. For that, you have to include one more feedback path. That's all. You have to include one more feedback path which consists of G4 plus G, which consists of this G2 plus G3. It should consist of that G2 plus G3. That's all. One more feedback path you have to include. From where it has to draw is a question. That is also there. That's why always move this takeaway point away from this summing junction. Away from this, always. So if you want to move this away, means this side only, not this side, because we have no rules for that. We didn't study any rule to move across summing junction. We can move after a block. We have rule. If you move across this, it is not multiplied by G2 plus G3. That's why we have to divide. That's why I can move here. In this diagram itself, I will move. I will move. In this diagram itself, I move. Then what we have to do? Divide by G2 plus G3. I understand. Consider now red line. Don't let us remove this part. If you remove this, so I moved this point from here to here. Then what happened to the block? The block becomes G4 plus G3 upon G2 plus G3. Am I correct or not? Because it is not multiplied by this. Now it is multiplied. That's why we should divide by G2 plus G3. That's all. G2 plus G3. Now we can convert this block by using 7th rule. If you convert this block into 7th rule, apply 7th rule for this. 7th rule. For this also you apply 7th rule. 7th rule. Then what you will get? What you will get for this G2 plus G3 upon 1 plus G2 plus G3 multiplied by G1. This is for first block. For this block, first block, I got this. So I have to draw that summing junction is there, R is there, feedback is there. This feedback is there. This is plus. This is plus. This is plus. I will put here. This is minus. Feedback is negative. So after this, G5 is there. G5 is there. Now this is coming here. G5 is in parallel with G4, G5. Therefore, I can add G5 with that. Am I correct or not? Can I add? Because this, you follow my pen. This red line is in parallel with the G5. Am I correct or not? This red line, follow this red line. This G4 plus G3 upon G2 plus G3 is in parallel with the G5. Am I correct or not? Therefore, what I can do is I can add with the G5. So G5 plus, so what I can write is G5 plus G5 plus G4 plus G3 upon G2 plus G3. G5 plus G5. G5 plus G4 plus G3 upon G2 plus G3. Now, up to this we came. This block, this summing block can be written like this: one summing block, another summing block. In this summing block, this G4 plus G3 upon G2 plus G3 came here. Here, the feedback path is coming. This unity feedback path is coming. Unity feedback path is coming. Therefore, this G6 can be written as 7th rule. 7th rule. G6 upon 1 plus G6 multiplied by 1. G6 multiplied by 1. Why 1? Because unity feedback. No block is there. Therefore, 1. No block is there. The value is 1. That's why multiplied by 1. That's all. Now the feedback as G7 is there. G7 is there. That's all. Now we have to multiply all forward paths. We have to multiply all forward paths. What is first block? What we have? G2 plus G3 upon 1 plus G2 plus G3 multiplied by G1. This is first block. We have to multiply with that. Oh, I wrote in the previous slide. Okay, no problem. G5, if you take LCM, what you will get? G5 multiplied by G2 plus G3. G5 multiplied by G2 plus G3 plus G3 plus G4 whole divided by G2 plus G3. Am I correct or not? I'm taking LCM, that's all. I'm taking LCM for this block. If I take LCM for this, G2, G3 is LCM. That's why G5 should be multiplied by G2, G3, G4, G3. So that's all. That's all. Multiplied with, what is the another block? G6 upon 1 plus G6. G6 upon 1 plus G6. So G2 plus G3 getting cancelled. This becomes a single block. This is G7. Some students, why they put G1 upon G2, why they put, because this is G1, G7. Don't consider those suffix numbers. Suffix can be given. For this, we can give G7. Here you can give G2. Suffix number is to distinguish, that's all. It need not be in the particular sequence. Any name can be given to any transfer function. That's all. Now we have to apply 7th rule. That's all. So what in the numerator, forward path transfer function I am writing? G2, G5 plus G3, G5 plus G6. Here also G6. G6 is outside, That's why we have to multiply by G6. Then here, what you will get? G3, G6 plus G4, G6. Am I correct or not? Check whether I am correct or not. G6 is outside for all. That's why we have to multiply everything by G6. Then in the denominator, what you will have? 1 plus G1, G2 plus G1, G3 multiplied by 1 plus G6. So I am applying 7th rule. That's why 1 plus negative feedback. Here negative feedback. Here negative feedback. That's why 1 plus. We have to write as such G6, G2, G5 plus G3, G5, G6 plus G3, G6 plus G4, G6 upon 1 plus G1, G2 plus G1, G3 multiplied by 1 plus G6 multiplied by what is in the feedback, G7. Now, if we take LCM, these two will getting cancelled and the 1 plus 1 becomes this denominator part. So we can write one more step. Therefore, the final answer is G2, G5, G6 plus G3, G5, G6 plus G3, G6 plus G4, G6. 1 plus G1, G2 plus G1, G3 plus G6 plus G1, G2, G6 plus G1, G3, G6. Plus G2, G5, G6, G7 plus G3, G5, G6, G7 plus G3, G6, G7 plus G4, G6, G7. How many elements? 1, 2, 3, 4, 5, 6, 7, 8, 9, including this one, 10 elements. That's all. Now we have to solve this by using signal flow graph. Now we have to convert this into signal flow graph. For that, for every junction, we have to name a node, including source node and destination node. This is source node. C is destination node. So this is second node, third node. This is fourth node. This is fifth node, sixth node, seventh node. This is eighth node, ninth node. This is 10th node. This is 11th. So 1 to 7. 1, 2, 3, 7, 11. 5 is a 8 is here. Below 3, 8 is there. Then 9, 10. Below 4, 9. Below 9, 10. That's all. So 1 to 2, what is the gain there? 1. 2 to 3, unity gain. 3 to 4, gain is G2. 4 to 5, no gain. 4 to 5, no gain. 5 to 6, what is gain? G5. 6 to 7, G6. 6 to 7, G6. Then 3 to 8, direction is important. 3 to 8, gain is unity. 8 to 9, G3. 8 to 9, G3. 9 to 4, 9 to 4, unity gain. Here, G4. G4, 8 to 10 gain is G4. 10 to 9 to 10 only. 9 to 10 only. Then 10 to 6, one path is there. Gain is unity. 7 to 2. 7 to 2. Gain is minus G7. 5 to 2. Gain is minus G1. That's all. Anything I missed? 7 to 6. 7 to 6 gain is minus 1. Why minus 1? Negative feedback. Here you can notice that negative sign is there. Therefore, minus 1. Now, how many forward paths to reach from 1 to 11? This is gain 1. How many forward paths are there? P1 equal to 1, 2, 3, 4, 5, 6, 7, 11. So what are the gains? G2, G5, G6. Then any other forward path you can come. Any deviation is there, you have to notice. At 3, you can come down. So you can go to 8, then 9, then 4. Therefore, second forward path is G3, G5, G6. Third forward path, you can come down here. G3, there are two paths. One go up, another one go down. Therefore, G3, G6 is another forward path. G3, G6. What is the path? 1, 2, 3, 8, 9, 10, 6, 7, 11. 7, 11. 7, 11. That is one path. G3, G6. That's all. P4, another forward path. You can come at the same point 3 to 8, then G4 through G10 you can go. Therefore, G4 will come. G4, but you cannot travel this way. But G4, G6. G4, G6. Here, G3, G5, G6 is there. How many forward paths? You can see that. If you have any doubt, you can see the block diagram. How many in the numerator? How many elements in the numerator? 4. Definitely 4 forward paths will be there. You can check with that also. Even with the block diagram reduction, you can check the signal flow graph. In the denominator, how many elements you have to get? 10 elements you have to get. Already I counted and wrote 10. So, while writing number of loops, you can check that. Okay, only 4 forward paths. Let us check whether it is correct or not. That also possible. G3, G5, G6. G3, G5, G6. It's there. G3, G5, G2. One is G2. This is G2. G2, G5, G6. That is also there. G3, G6, G4, G6. That is also there. Forward paths are correct. I can cross-check with the block diagram reduction. Now I can find the delta. To find delta, what and all we have to find? Delta 1, delta 2, delta 3, delta 4. We have to find delta 1. What is delta 1? Delta 1 is also a delta part of graph which is not touching the forward path. The forward path is for G2, G5, G6. The part of graph which is not touching the forward path is 8, 9, 10. Or the 3 nodes are not touching the forward path, but there is no loop. 8, 9, 10 is not loop. Why it is not loop? Direction is not correct. Direction is not in the unidirection. This one-way traffic is there. That's why it is not loop. Therefore, delta 1 is 1. Delta 2, G3. The part of graph which is not touching the forward path is only 10. No loop is there. That's why that is also 1. Delta 3, G3, G6. G3, G6. Part of graph is 5 and 10. No loop is there. No loop is there. At 5 and 10, no loop is there. That's why G3 also 1. G4, G4, G6. Part of graphs are 9, 5. At 9 and 5, it has loop. It has loop. This loop is there. G2, G1 is there. G2, G1 loop is there. But it is touching at 2. Forward path. What is the forward path? 1, 2, 3, 8, 10, 6, 7, 11. For that, you got G4, G6. That is also no loop. That's why that is also 1. Now we have to find delta. Delta equal to the transfer function. To find delta, we have to find all loops. L1. L1 equal to what? First loop. This is one loop. This is loop 1. What is that loop? Minus G1, G2. Minus G1, G2. This is another loop. Loop 2. Loop 2 is G6 minus G6. Minus G6. Another loop I can find. If I travel 2, 3, 8, 9, 4, 5. If you travel like that, I'll get one loop. That is L3. If I travel like this, I can find one loop. What is that loop? Minus G3, G1. That is one loop. L5. L5 equal to G2, G5, G6, G7. That is one loop. L6. L6. G3 minus G3, G5, G3, G5, G6, G7. L7 equal to G4, G6 minus G4, G6, G7. 7 loops are there. Any other loop? What are the non-touching loops? L1, L2. That is non-touching. L1 and L2. That is G1, G2, G6. L1, that is G3, G1. What is that? G3, G1, L3. L3, L2. That is also non-touching. Therefore, G3, G1, G3, G1, G6. L7 is L7 equal to G3, G7 minus. That is one more loop. Now 7 plus 2, 9 plus 1, 10. We got, therefore, the transfer function is P1 delta 1 plus P2 delta 2 plus P3 delta 3 plus P4 delta 4 upon delta. Delta where delta equal to 1 plus 1 minus L1 plus L2 plus L3 plus L4 plus L5 plus L6 plus L7 plus, that's all, plus L1, L2 plus L2, L3. That's all. I finished. Block diagram, reduction technique. Let us once again see. Here, this G3 and G4 are in parallel. That's why we can add them together. G3 plus G4. Another thing is, here G3 we cannot simplify this part because there is a takeaway point that should be moved from here to here.
Yesterday,
move this, what will happen
G7.
is G5 has to be divided by
is
G7.
positive.
G6. So let G5 upon G7. G2 that is coming from here. One summing junction is there. G8. That's all. Therefore, G9 equal to. Now this can be simplified. This is equal to G9. G9 equal to G7. 1 minus G6 G7. Therefore, this can be written as R of S G1 G3 plus G4 G9 that is cascaded. This is G10 G2 is as such. So where G10 equal to G5 among G7. Now we can move this also. G2 also we are moving away from that. And this can be called as G11. This together, G3 plus G4 multiplied by G9 can be called as G11. G11 equal to G3 plus G4 multiplied by G9. So what we will get is R of S multiplied by G1 G11 G2 by G11. Another one is G7. Both are added together and it is subtracted. Here one more feedback is there, that is G8. Between these two, one feedback is there, that is also positive. Now we can find G13 equal to, this can be called as G13. G13 equal to G1, G11 upon 1 minus G11 G8. G11 upon 1 minus G11 G8, that is G13. If you multiply this G13, okay. Now this diagram becomes, we have to substitute G13. Now what we will get is G1, G13, G13, this is equal to G12. G12 equal to G2 among G11. So now we'll get G12, one feedback. Another feedback is G10. This is negative feedback. So finally, G10 and G12 can be added together. Therefore, we can write R of S equal to G1 plus G13 and G12 plus G10. That's all. Therefore, final transfer function is T of S equal to forward path transfer function upon 1 plus G12 plus G10 multiplied by G1, G13. Now we have to substitute all these values. For that, the first step is G1, G13 equal to, what is G13? G13 is G3 plus G13 is G1, G13 is equal to G11, okay, G11 upon 1 minus G8, G11. That is also equal to G1, G13 equal to what? G13 is G11 upon 1 minus G8, G11. This is 13. Now we can substitute G11 here. G1, G13 equal to G1. G11 is G3 plus G4 multiplied by G9. That is G11 whole divided by 1 minus G8, G3 plus G4 multiplied by G9. That is G11 is substituted now. Now we have to substitute G9. G9 equal to what? G9 equal to G7, G1, G3 plus G4. G9 is G7 upon 1 minus G6, G7 whole divided by 1 minus G8, G3 plus G4. G9 is G7 upon 1 minus G6, G7. So we got G1, G13 like this. If you simplify this, what you will get is these two, 1 minus G6, G7 can be cancelled and it can be multiplied instead of 1. What you will get is G1, G3 plus G4 multiplied by G7 whole divided by, I am going to cancel this part and this part, divided by 1 minus G6, G7 minus G8, G3 plus G4, multiplied by G7. So we got G1, G13. The numerator part we got now. The denominator part we have to find. The denominator part is G12 plus, the denominator part is G12 plus G10. That we have to find. G12 plus G10 equal to, G12 equal to what? G12 equal to G2 by G11. G2 by G11 plus G10 equal to G5 by G7. That is equal to G11 equal to G3 plus G4 multiplied by G9 plus G5 by G7. If you simplify this, what you will get is, G2, G7 plus G5, G3 plus G5, G3 plus G4, G3 plus G4 multiplied by G9, G3 plus G4, G9, G7. This can be substituted in the T of S. If you substitute in T of S, what you will get? We got the numerator and denominator separately. if you substitute that in the G1, G13, in place of that, if you substitute that, this is denominator part. Denominator part. If you substitute that in the transfer function, you will get G1, G3 plus G4, G7. That is, we got for numerator. This is for numerator. That we are substituting. G1, G3 plus G4 multiplied by G7 divided by 1 minus G6, G7 minus G8, G3 plus G4, G7 whole divided by, this is for numerator. This is for numerator. Denominator 1 plus the same numerator we have to write, that is G1, G3 plus G4, G7 whole divided by 1 minus G6, G7 minus G8 multiplied by G3 plus G4 multiplied by G7. This is for numerator. For denominator already we derived, that is G2, G7 plus G5, G3 plus G4 multiplied by G9 divided by G3 plus G4 multiplied by G9, G7. So here we are getting G7 is getting cancelled. G3 plus G4 is getting cancelled. Therefore, this is equal to, now what is this part? The denominator and the numerator, and the denominator, part of denominator in the denominator has to be getting cancelled. For cancel that, we are taking LCM. LCM means in place of 1, we have to write this. Therefore, we will get numerator G1, G3 plus G4 multiplied by G7 whole divided by G7 whole divided by, I am writing this in place of 1. 1 minus G6, G7 minus G8 multiplied by G3 plus G4 multiplied by G7. So we are writing for 1 alone plus G1 only there, then G2, G7 plus G5, G3 plus G4 into G9. G9, this G9 and G9, we can cancel this and we can write G9 here. So that G9 can be written here and the G9 can be cancelled. Okay. So numerator is simplified, denominator we have to simplify. So numerator is G1, G3 plus G1, G3, G7 plus G1, G4, G7. That's all. This is numerator. Denominator is, we have to find, that is 1 minus G6, G7 minus G8, G3, G7 minus G8, G4, G7 plus G1, G2, G7, G9 plus G1, G5, G3 plus G1, G5, G4. So 9 has to be substituted. That's all. That is the only thing that is not in the G2, G7, G9 here cancel. Here divided by G9. This G9 here cancelled, here it is not cancelled. Then what you will get? G1, G5, G3, G1, G5, G3, because G9 getting cancelled. Here, G9 in the denominator. Here, G9 must be in the denominator. That's all. So, G9 in the denominator. This is getting cancelled. Here, not cancelled. Therefore, it should be in the denominator. G1, G2, G7 upon G9. Okay. The denominator can be written as P of S equal to, the numerator is G1, G3, G7 plus G4, G7, G4, G1 whole divided by 1 minus G6, G7 minus G3, G7, G8 minus G4, G7, G8 plus G1. I am going to substitute for G9. G9 equal to G7 G2 G7 upon, we'll write one step here. Otherwise, G5 G3 G1 plus G1 G5 G4. That is what we wrote it. G1 G5 G3 G1 G5 G4. Here G9. So this part, instead of G9, this part is equal to G1, G2, G7 whole divided by G9 equal to G7 upon 1 minus G6, G7. G7 getting cancelled and it becomes the numerator. Therefore, we can write now G1, G3, G7 plus G4, G7, G1 whole divided by 1 minus G6, G7 minus G3, G7, G8 minus G4, G7, G8. G1, G2, G7 and this becomes numerator. 1 minus G6, G7 plus G5, G3, G1 plus G1, G5, G4. Then one more step. G1, G3, G7 plus G4, G7, G1 whole divided by 1 minus G6, G7 minus G3, G7, G8 minus G4, G7, G8. G8 minus G4 here plus, okay, G8 minus G4, G7, G8. This plus G1, G2, G7. Because of this one, we multiplied minus G1, G2, G1, G2 minus G1, G2. G7 is cancelled, you know. That's why this G7 will not come. G1, G2 minus G1, G2 G6, G7 plus G5, G3, G1 plus G1, G5, G4. Now we will convert this into signal flow graph. Node 1, node 2, node 3, node 4, node 5, node 6, node 7, node 8, node 9, 10, 11. 11 nodes are there. 1 to 2 is unity. 2 to 3, G1. 3 to 4, again unity. 4 to 5, G3. 5 to 6, again unity. 6 to 7. 6 to 7 is what? 6 to 7 is unity. 6 to 7 is again unity. 7 to 8. 7 to 8 is G7. 8 to 11 is again unity. Then 9 is below 2. This is, sorry, this direction. -1. Here below 4, 10. Below 4, 10. 10 unity. G2. This is G2 plus G2. Then 7. From 7, where is 7? This is 7. 7 to G5. 7 to 9. 7 to 9. Then 8 to 7 plus G6. Then same 8 to 3. 8 to 3. G8 plus G8. That's all. Finished. G4, 10 to 5 is there. 10 to 5. That is G4. That's all. So now, what is the what are the forward paths? P1 equal to G1, G3, G7. G1, G3, G7 plus another forward path is you can come this way. G3 can G6. This is G6. 8 to 7. Not 8 to 7. That is G6. G6. Okay. Now forward path. This is one forward path. G1, G3, G7 plus G1, G4, G7. G1, G4, G7. What is the numerator? G1, G3, G7 and G4, G7. We immediately got numerator. So there we struggled like anything to get numerator. Here immediately we got numerator. Only thing is denominator we have to get. Denominator to get what is delta 1, delta 2 we have to find. Delta 1, delta 2 are delta 1 equal to what? Delta 2 equal to what? There is no part of graph which is having loops. Therefore, delta 1 is 1. Delta 2 is 1. Therefore, numerator we got P1 plus P2. This is P1 plus P2. I directly wrote. Because delta 1, delta 2 are 1, 1. So we got the numerator. Denominator, to get denominator, we have to find all loops L1. L1 equal to what? L1 equal to L1 equal to, we can write G3, G7, G3, G7, G8. Can I write? Positive. L2 equal to G6, G7. L2 equal to G6, G7. Am I correct? One more loop I am finding. G3, G7, G8. Instead of G3, I can consider G4 also. Therefore, L3 equal to G4, G7, G8. Can I tell like that? What is the 3, 4, 10? What is this? 3, 4, 10, 5, 6, 7, 8, then come to 3. So that is on closed loop. G4, G7, G4, G7, G8. One more feedback path here. G1, G2, L4. L4 equal to G1, G2. That is minus. Why? Because minus 1 is there. That's why minus. One more feedback. L5. L5 equal to G1, G3, G1, G3, I am following this 2, 3, 4, 7 through G5 I can come. Or G1, G3, I cannot travel this way. I cannot travel this way. Therefore, G1, G3, G7, G1, G3, G7 and G5. That is one more. G5. Any other loop? Any other loop? G1, 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 G3 only. G1, G3, G4. Okay. G1, G4, the same way G1, G4, L6 minus G1, G4. Instead of G3, I can consider G4, G5. So 6 loops I got. 6 loops I got. Any other loop? How many we got there? 9. 8. Yes, 8. So here L1, this loop, what is this? This loop and this loop is non-touching. Therefore, I can say L4 and G7, G6. What is that? L2. L2 equal to minus G1, G2, G6, G7. That is not touching. So G1, G2 we got, G6, G7 we got, G3, G7, G3, G7, G3, G7, G8. Yes, L1 we wrote. G4, G7, that is also G4, G7, G8, G1, G3, G5. We wrote G1, G4, G5. Okay. 1, 2, 3, 4, 5, 6, 7. 2 more we have to get. So G6, G7 we got. Denominator I will write here. 1 minus G6, G7 minus G3, G7, G8 minus G4, G7. This is a block diagram reduction. Block diagram reduction, denominator. G4, G7, G8 plus G1, G2 minus G1, G2, G6, G7 plus G1, G5, G3 plus G1, G5, G4 plus G1, G3, G7 plus G4, G1, G7. Here, whatever we got as L1 will tick. G1, G2 we got. G3, G7, G3, G7, G8 we got. G6, G7, that is also we got. G4, G7, G8 we got. G1, G3, G5, that is also we got. G1, G4, G5, that is also we got. G1, G3, G6, G7. G1, G3, G1, G3, G6, G7. G1, G2, G6, G7. Minus G1, G2, G6, G7. That is also we got. The left out these two. G1, G3, G1, G3, G7, G4, G1, G4, G1, G4, G7. These two are forward paths. That is forward path. Yes, we got all. This I wrote additionally. So we got everything. In single stroke, we got everything. To demonstrate how difficult to get block diagram reduction, that's why this sum. So we got all L1s. These are all we have to put minus sign. Check the sign. G3, G4, G8, we got positive here. In the block diagram reduction, we got negative. Yes, because in the formula, 1 minus, what is formula? 1 by delta sigma pk delta k, delta equal to 1 minus. Because of that, these are all positive. That's why we are getting minus. That is sign also we are getting correctly. So these are all we get minus. Therefore, delta equal to 1 minus L1. That is G3, G7, G8 plus G6, G7 plus G4, G7, G8 minus G1 minus G1, G2 minus G1, G3, G5 minus G1, G4, G5. That's all. Plus, what is the formula? 1 minus, these are all again plus 2 non-touching loops. That is minus G1, G2, G6, G7. That is in minus only in the block diagram reduction. So we got the correct denominator, block diagram reduction as well as signal flow graph. So this sum is solving by signal flow graph is simple. If you go for block diagram reduction, it is very time consuming. Time consuming, that's all. Not complex, time consuming, and we should be careful. So this is denominator, this is numerator. In signal flow graph, this is numerator, this is denominator. We got the correct result. And this is very simple, but this can be directly simplified because G1 upon G1 plus H3. Am I correct? Can we simplify this? No problem. Yes, we can simplify. That's why this becomes these two are parallel. That's why these two can be combined. combined G1 upon G1 plus G1H3 G1H3 G2 G3 H2 minus and sorry, one more is required, minus. These two can be combined. This is 1, this is H1. Therefore, 1 plus H1. We can put 1 plus H1 and we can connect here. C of S. Now, the G2 can be combined with this and it can be reduced to this can be, this part can be reduced. This part can be reduced. G2 can be multiplied with that and it can be reduced. Therefore, G1, G2 upon 1 plus G1, H3. This is numerator. This is numerator. Whole divided by 1 plus G1, G2 upon 1 plus G1, H3 multiplied by H2. That's all. This is we got for this block, the red block, red circle. Now it is multiplied by G3, multiplied by G3. This is 1 plus H1. Now, first we have to simplify this. What is that? G1, G2, 1 plus G1, H3 whole divided by 1 plus G1, H3 plus G1, G2, H2 whole divided by 1 plus G1, H3. These two getting cancelled. So this block is reduced like this. Reduced like this. Now we can go for final diagram. That is G1, G2 divided by 1 plus G1, H3 plus G1, G2, H2. G1, G2, H2. This is multiplied by G3 R of S. This is minus, this is plus 1 plus H1 C of S. That's all. Now, if we simplify this using 7th rule, what you will get? G1, G2, G3, 1 plus G1, H3 plus G1, G2, H2 whole divided by 1 plus G1, G2, G3 divided by 1 plus G1, H3 plus G1, G2, H2. This is within bracket multiplied by 1 plus H1 feedback path. So if you take LCM of this, you will get this part will be getting cancelled. We can cancel this part and this part by taking LCM. So G1, G2, G3 upon 1 plus G1, H3 plus G1, G2, H2. This is numerator. Whole divided by 1 plus G1, H3 plus G1, G2, H2 plus G1, G2, G3 1 plus H1 whole divided by 1 plus G1, H3 plus G1, G2, H2. This is denominator. This and this getting cancelled. Therefore, this is equal to numerator becomes G1, G2, G3 whole divided by 1 plus G1 H3 plus G1 G2 H2 plus G1 G2 G3 plus G1 G2 G3 H1. That's all. This is the final transfer function. But this much you can solve by using Mason's gain formula. Let us assume that this is a signal flow graph. As if it is a signal flow graph, node 1, 2, 3, 4, 5, 6, 7, 8, 9. Only one forward path. What is the forward path transfer function? G1, G2, G3. Yes, we are getting. Therefore, P1 equal to G1, G2, G3. Delta 1 equal to 1 because no part of graph which is not touching the forward path. Let us assume that block diagram itself as a signal flow graph. So now, what are the loops are there? L1. L1 equal to what? This is G1. This is minus. Therefore, minus G1 H1. L2 equal to, this is second loop, G1 G2 H2 minus G1 G2 H2. L3 again, this is G1 G2 G3 H1 minus G1 G2 G3 H1. One more loop, L4, that is L4 equal to the same path, this path, we have the same forward path is same, G1, G2, G3, and we have to follow this path. Then L4 is minus G1, G2, G3. How many elements? 1, 2, 3, 4. 4 elements. Here we got 4 loops. Yes, we got. To check G1, G1, H3. G1, H3, first loop. G1, H3 we got. G1, G2, H2 we got. G1, G2, G3 we got. G1, G2, G3, H1 we got. Yes, all we got. Therefore, the final transfer function is T of S equal to P1 delta 1 among 1 plus L1 plus L2 plus L3 plus L4. 1 minus L1 plus L2 plus L3 plus L4. All are in negative, that's why automatically you will get positive values.